Hi everyone, my name is Tristan and I'd like to start a little bit about me. To kick it off, I graduated as a mechanical engineer from the University of California, Irvine in 2016. Then right after I graduated, I worked at GoGo in-flight connection for about 2.5 years. And then at the end of 2018, moved to Saratech as a structural engineer, where I've been working here for about a year and a half now. So that's a little bit about me. Let's get right into it. Today we'll be outlining what the NX wizards are, and then some of their advantages and limitations. Then we'll end off with a demonstration of the stress wizard. There are two other wizards outside of this, the vibration and the durability wizard, where I will cover those a little bit in detail, but not as much as the stress wizard. Then we'll end off with how can Saratech help you, at least with NX wizard, how can we maximize your use of it, and some other resources that are available. So jumping right in, I'd like to preface with what a wizard is, as just to get us all on the same page. It is a generic term for a program interface or tool, which is used to assist with complicated or typically uncommon tasks. Usually it's in the form of a step-by-step guide, and it's there to help and make things easy or make a task easy. One good example of this, if you've used Microsoft Office in the early 2000s, you'd probably run into this guy named Clippy. He'd show up on the bottom right corner, and whenever you click some buttons, he'd ask you if you ever needed help with that. So that is what a wizard is. Now we can jump into what the NX wizards are. Unfortunately, we don't have a cute little character like Clippy, but we do get some nice interface. Like I mentioned earlier, there are three wizards. There is the stress wizard, which helps you with static analysis, the vibration wizard, which helps you with a modal analysis, and the durability wizard, which helps you with life cycle or fatigue analysis. So they're all there. It's an easy way to make your design better. It's there to help you conduct stress analysis. If you're not too familiar with where these are, if you were to open up NX, you have the resource bar on the left, and you have this rainbow colored box here with a magic wand tool next to it. If you click that, it'll open up this panel where you can find these stress wizards. And I'd like to mention that the stress wizard and the vibration wizard are part of the NX mock bundle. So if that's the bundle that you have, then you likely have this tool already. The durability wizard is an optional add-on. So if anybody were interested, they can add it on to their bundle. So now that you know a little bit about the NX wizards in general, I'd like to talk about them in a little bit more detail. So first off, the most common and the most basic is the NX stress wizard. It is a static analysis solver or a linear statics solver, which helps predict stress levels in a part when applying certain loading conditions to them. It's an indicator of how strong that part is, and it can show you where the weak points are as well. So with all of that information, it can tell you where the highest stress levels are, and if it's not up to your performance standards, then you can easily beefing it up or thicken the area that's a little bit weaker, and then rerun the analysis to see if the change that you made your part perform as expected. As I mentioned earlier, this is part of the NX mock bundle. And so is the next one, which is the NX vibration wizard. This wizard is the modal analysis solver, which is a study of the part's dynamic and vibration characteristics. Unlike the stress wizard, it provides you with details about the part itself instead of its reactions to certain loads and forces that you apply to it. So the properties that it gives you is the natural frequencies, which is the rate that it will vibrate at, and then its mode shape, which is the deformation or the displacement that it will move. If you see the picture on the right, the mode shape is that animation, and then the frequency is the speed of that movement. And this is a little bit more technical, but the reason it could be important is that if you have this part, say the part on the right, attached to, say, a fan that's operating around the same frequency, then this part, or I'm sorry, if they're acting in the same frequency, then they may resonate, which will amplify the loads that this part sees and can cause it to have catastrophic failure earlier or at a less magnitude than earlier than you originally expected. As I mentioned earlier, this is also part of the NX mock bundle. Lastly, we have the NX durability wizard, which is the fatigue analysis solver, or where it studies the part's strength and its life cycle. It's a good indicator of the part's durability and how long it will survive under a cyclical load, and how many cycles it will take for that part to break. A good visualization or an example of this, just to get you guys thinking, if you were to have a paper clip that was unwound and straight, and if you were to bend it to the left and then bend it to the right, we can call that one cycle. And after how many cycles does it take for that piece or that end to snap off? That's essentially what the durability wizard will tell you. Unfortunately, this is not part of the NX mock bundle, but as I've said, it's an optional add-on. So now that you guys know a little bit about the wizards themselves, I can talk about some of their advantages. I've geared this a little more towards designers, as this is an entry-level program and it's in NX, so it's very easy for you guys to access. One of the advantages that I have, and as I've been saying this entire time, it's very easy to use. It gives you step-by-step instructions. I added an image to the right of what that interface looks like. You get some instructions here and then a couple push buttons to help you along the way. On the left, you have all the steps that you'll be going through, and then several next buttons will get you to the finish line. Next advantage I have is that it's a first look design verification. Typically, designers and stress analysts go back and forth between design changes. Sometimes you skip that step of stress and analysis altogether. So this is a good look at how your part will perform under whatever loads you expect of it. The next advantage I have is to quickly evaluate various loading conditions. So if you have a part that you expect to see different or to be handled in different types of ways, and it will see different types of loads, then it takes about 5 to 20 minutes, depending on your expertise or how complicated your model is, to do a whole analysis. So it's fairly quick. So every, let's say 20 minutes, you can run a new load and see how the part reacts. Lastly, I have, you can quickly update the model for new analyses. What I mean by this is that since it's all integrated within NX, you can do your stress analysis, see where the part's weak, for example, and then go back to your design module and do a design change in that area, either make it thicker or maybe change the shape. And then you can bring it back to Stress Wizard and see how it performs with the changes that you've made. So these are some of the advantages that I've seen, but there are limitations as well. This is an entry-level program. It's far from an advanced solver, but it does have its uses. I'd like to bring out these limitations just so that you guys know some of the things that the wizards can't do. The first thing I have is that it only works on single components, or it can analyze one part at a time. So if you have an assembly or an installation, I'd say that the NX wizards wouldn't be well suited for that type of analysis. Next, we have it only works with one element type, which is the tetrahedral solid. It's not too bad, as the tetrahedral solid is pretty versatile. It will take on any complex shape that you throw at it, and the results that it gives are pretty accurate. Then we have no mesh manipulation, which you'll see in the software, it will ask you for an element size. And once you input that element size, that is what you get. There's no finer tuning of the mesh. There are also no other analysis types than the ones that I've mentioned. So we only have linear statics, modal, and fatigue. There aren't thermal or nonlinear or some other analysis types. Lastly, I have limited display or post-processing interface. Stress analysts have to end up writing reports usually. And for these reports, we like to add pretty pictures. So NX Wizards makes it a little hard to do that. So those are some of the limitations I thought you guys might find helpful in knowing what you are dealing with here. So with all that being said, you know a little bit about what they do. So we'll jump into the demo from here. Here in this slide, I've listed out what is needed for an analysis. For the stress wizard and the vibration wizard, we have very similar requirements. You need a solid body, constraints, and materials. You'll see for stress wizards, you would need loads as well, because it will tell you how it will react, how the part will react to them. And then the durability wizard is a little bit different. It requires a static stress solution. So it does require stress wizard to be ran first, and then you'll give it loading and analysis parameters where it will slowly solve, or where you give it options on how it wants to solve for your life cycles. So with that being said, I will start the demo now. So now that we're in NX12, I've pre-created this part. It's a simple I-beam just for the demonstration. And from here, we can get started. So I opened up the part. And as I mentioned earlier, you can find the wizards on the resource bar on the left, where this rainbow colored box with a magic wand tool is. Then we're going to go into the three of them are here. We will be looking at the stress wizard, and then you get this pop-up. You get several different templates. I believe that if you click all of them, it will give you the stress wizard, but I believe some of them are labeled some third-party processing apps like MSC Nastran or Abacus. I believe that the wizards can use third-party solvers to do the analysis and use NX as the pre-processor. So in case you don't have NX Nastran, the wizard should still work for you. Then I can choose a name. I'll use the default name that it added, and then make sure that you're in a writable folder. If it only has read access, you may get some errors later. So I'll kick that off, and it will start preparing me for using Stress Wizard. And it will give me this interface, as I've shown earlier. The first step is to select a solid model. I could select this one, but I'd like to show you what the push buttons do first. The first one is to hide all unselected objects. So if you do have an assembly here and you want to make sure that you clicked on the right component, you can click this and it will hide everything except for the one that you've clicked. Unfortunately, I only have one, so it just hid that one since I didn't click it. But the next button is to unhide all the parts that were originally hidden. So for this step, I'll simply click our solid body and click next. Next, we have the loads that we want on the part. There are 5 different loads. First one is a force load. Next is torque, then pressure, bearing, and gravity. For this demonstration, I will be doing a force load on the I-beam. And the first step it gives us is to choose where we want to apply, which feature do we want to apply it to. You can choose a face, an edge, or a point. For this demonstration, we will choose an edge and we'll choose the end of the I-beam. And then we click next, and so it knows to apply it there. And then we choose a magnitude and direction. There are 2 ways to do this. You can click this push button and you can apply a load in each of the 3 coordinates, or you can apply a load with a direction vector. We will be applying a 50-pound load to this end, pounds in the negative y direction, but you could choose point to point or some angled vectors. We will be applying this to the negative y direction. You can see that it's pointing up, so we want to reverse that and then click next. From this, you can see that it added red line or red arrows pointing downward. That way we know that it was applied as we expected. From here, we can click constraints or click next, and it will bring us to the constraints. The three constraints that we have are fixed, pinned, or sliding. For this demonstration, I will just do a simple fixed end. And so I'll click fixed, and then you get the same option to choose which feature you want it applied to. I want to do a face, and I want to do it to this end. So I'll turn this over and apply it to this face and click next. And we'll know that it worked because it will add these blue X's onto that face. So as you can see, the loads and the constraint is as we expected. I'll try to get this into a view, the original view that I had it, and then we'll click next. Lastly, we need to add a material. All these materials are inside of the NX library, so if you need to see more information, you can look there, but we have some metal, some plastics. I don't believe there's anything in polymer or ceramic by default. As I said, this is all coming from the NX library. In other, we have epoxy, but for this demonstration, I've predetermined it, the material to be aluminum 6061. So I'll click that and I'll click next. And lastly, we need to add a mesh size. The stress wizard will automatically calculate what it thinks it should be. As a rule of thumb, I'd like to divide this by 2 or 4, but you want it to be, you want to have at least 2 elements within the thickness of your thinnest part. Usually that's a good rule of thumb. For this, I've determined it to be 0.1, and we'll click next so that it starts generating the mesh. This might take some time if you have a much smaller or finer mesh size. We'll zoom in. It looks, if you guys can see, we do have 2 elements through the thickness, so I believe this should be fine, and I like the way it looks. So here we get to start the structural analysis by clicking this button. And once that's clicked, it will open up this information window, telling you a little bit about what it's doing. This is writing out the input file that's getting put into your third party, or not necessarily third party, but your processing software, Nastran. And it will give you some information about the model as well. C tetra is the number of elements that it had created. The force is the number of nodes that it's applying forces to. Grids are the number of nodes there are, and some other things. So once it gets down here to no further action is needed, that means it's all done with the analysis. Sometimes it'll give you errors, but as long as you're following the steps correctly, it's very unlikely to happen. Some other important things in here is the strain energy error. It says that most engineering applications require it to be less than 5. We have it less than 5, so that's fine. And then you have the overall model confidence level, which is basically 100 minus the strain energy error, and it's at 98%. So we can be fairly confident in the model. From here, we can close this information window, and we can click next. From here, we get results. I'll move this a little bit so you can see a little better. And the first results we get are the displacements. We can see that the max displacement is on the loaded end. So this is the fixed end here, and the loaded end gets moved the most. And it moves at 0.0249 inches. And I have a little example after this to do a theoretical calculation. So you could try to remember this number to see if we get pretty close. Next results option is the stress output. I guess it likes to default view it in that position, but it's a little hard to see. We can see at the loaded end, there's actually very little stress, and at the fixed end is the highest stress. So that is completely expected. And we can see that the stress levels are relatively low. And to confirm that, we have a safety factor as the last results view. And what the safety factor, this is a pretty cool tool. It will tell you whether the part will break or not based on the material that you've given it. So if it's between 0 and 1, then your part has essentially failed. It will likely break under the loads that you've provided. If it's between 2 and 3, it's really good. It's relatively safe, and it can likely handle double or even triple the load that you had originally applied. If it's between 1 and 2, it's good enough. It shouldn't break, but it's pretty close. You always want to have a good threshold or buffer so that you know for sure the part won't break. And then the last 3 push buttons we have here are the animation. I'll change this back to displacement just so we could see how the gradient changes with the application of the load. If I click play, it will deform the part from its undeformed state to its completely deformed state. And it does this in 8 steps, and you can see how the gradient changes. So it looks pretty cool. It's a good graphic. From here, you can pause it or you can stop it. If you want to choose to look at an animation for a different result, you'll have to click stop, click that, and then click play again. So that's pretty much what the Stress Wizard does. There's a last section here for report generation. And with this, we can create images. It'll automatically create images for you. And it seems to be a little bit slow, but that's fine. And once it's created the images, we can automatically generate this report. I think this is a really cool feature. As a stress analyst, I have to write a lot of reports. So if I were to ever use this and create my own template so that I could see the information that I wanted, then this could quickly generate a report that I can hand in to my boss or a customer. But in this report, this is the template that Siemens gave by default. We have what type of analysis we're doing, some information about the material. Some of it's undefined, you'll see, but a lot of these are not really relevant for the types of analysis that the wizards can do. So we don't need all of this information. If you were to make your own template, then you could probably cross all of that out. Then it gives you some details on the mesh, the types of solids or types of elements that it created, the property, the loads, the constraints, and then some more information on the results. I think the results are cool here because instead of just giving you this picture with very little detail, it will tell you the max and min of the X, Y, Z components individually, along with the resultant. And then it also gives you min principal, max principal, and max shear stress, which you don't get from the pictures as well because it only shows you von Mises. So that's what the reports give you, and it clusters those pictures that it took into this report. So that's it for the demonstration. That's how easy NX Wizard is to use. And from there, I have a little example here to show.
Hey, Tristan, we did have a question. Someone wanted to see if you could show them again how you generated the report.
Generated the report? Okay.
Yes.
If I go back to NX, right after results, I wonder if this will try to redo everything. If I go to results, right after we go to results, if you keep on clicking next, it'll bring you to the report section. And from here, you can click here to create the images. And then the second push button is to create the report. and it will automatically generate it based on the template that you have set. I believe under your preferences, you could change the template, but you have to create that template yourself if you want it to be different from the default one Siemens has provided. And then from here, you can click finish and you can save your simulation. Okay, I hope that answers your question. So moving on to the example, this is pretty much what we just did in the simulation software. I pulled this from the Practical Stress Analysis book by Flabel. It's a good read if you guys are ever curious about stress analysis. On the right here, we have what we did in the software. You have your beam here, your fixed condition on one end, and then on the other end, you have a load P that we applied in the negative Y direction. And based on this setup, Flabel has provided us with some equations. We're going to be looking at the max deflection equation. So on to the next slide, we have in this equation an applied load of 50 pounds. The length of the beam I didn't show you, but was 10 inches. A Young modulus from the aluminum 6061 of 10,000 KSI, and a moment of inertia of 0.069. This can be solved within Nastran as well, or not Nastran, but NX, which is cool and easy to do because solving for inertia isn't always easy. So from this equation, we get 0.024 inches, which isn't too far off from what we saw in the wizard. We had 0.0249, and I did a percent error check, and it's about 2 to 3% difference, which is kind of in line with the strain energy error that we saw in that confidence level. So it's not too far off. It's a very good estimate. And so now that we could see that the software works, that's the end of everything. I'd like to close out with how Saratech could help. Saratech has resources available for NX Wizards, along with our multitude of softwares. So this just doesn't apply to NX Wizards, but to all of our softwares as well. We have classes and training. I didn't go over too much on the vibration and fatigue or durability wizard, but I definitely have classes and training set up to provide that type of resource if anybody was interested. There's technical support if you're using the software and you run into any issues. And of course, we have design and analysis services in case you need any work done. We would like to help you succeed. And just to end things off, I'd like to reiterate some things. Just the biggest thing is that Stress and Vibration Wizard are part of the mock bundle. I know a lot of our customers have this bundle, so it would be a shame that this tool isn't being used, even though you have it. And it's a good time to mention that the Durability Wizard is still an optional add-on. With that being said, the NX Wizards is a quick and easy way to improve the design, and I appreciate you guys all for listening in. I'd like to turn things back over to Andrea to close things out.
Awesome. Thank you so much. If you are ready to take it to the next level, as Tristan said, we also offer engineering services to address your demand for advanced engineering capabilities, as well as additive manufacturing and training. So please feel free to reach out to us at info@saratech.com, and we'll be happy to help you with any information you may need on that. And make sure that you subscribe to our YouTube channel. There's lots of awesome videos, lots of great information on there. And our engineers spend a lot of time kind of building up that content. So I hope that you find it helpful. And thank you all so much for attending today, and hope you have a great rest of your week. And we hope to see you on the next session. Bye-bye.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.